Hello all, we are learning the Simulink library blocks. Okay, so here we will learn about the signal routing library, few blocks of signal routing library from the Simulink library. Okay, let's get started with from and go to block. Why we are using and how it will be used, that all things we will learn in this. So basic thing which theoretically I want to tell you that from and go to block allows us to pass a signal from one block to another without actually connecting them. Okay, as we know how PCB overcomes the lots of wiring connection. In that same there is from and go to block also useful where we are connecting like much more lengthy signal from one place to another place. Suppose if my input is here and this will be used here, so here I can connect that go to block, and from block I can connect here, so that signals will be passed from this to this without connecting that much long connection. Okay, same like how PCB is the lengthy or complex wire structure. So for that from and go to block will be helping for us. So they are linked with the tags on the go-to block. Once the go-to block can become a source of a multiple from block. One go-to block can also become a source of multiple from blocks as well. Okay, but one from block can be have only one corresponding go-to block. One from block can be having only one corresponding go-to block. So it helps the user avoids the crossing lines, especially in the case of many signals or multiple connections are there. It will be very helpful. So you learn much more details from in go to block as well. So the go to block passes its input to its corresponding from block. The input can be real or complex valued or signal or vector of any data types. Okay, so from and go to blocks allows you, like allows us to pass a signal from one block to another block without actually connecting them. Okay, so this is the main use of that from and go to block. So a go to block can pass its input signal to more than one from blocks as well, as we have just now gone met through. The same thing will be written here as well. So here you can see in this example. Okay, sine wave is connected to this go to block. Again, that from block, that same name is connected here. Then again, then we are saying the output is go. We can implement this example as well here. Okay, but first we will see here one example which I have already created. Here in a one constant, I have connected with the from that go to block. Okay, that constant name is a here. Okay, that constant 56 I have connected to this go to block, and this from block accepting this to here and displaying in a display. So here you can see in display I'm getting 56. If I'm changing this constant value to 45, and the simulation now, so you can see these changes will happen here as well, in display as well. Okay, once the model is simulated. Now you can see in display this value is passed as well. Okay, so go to block from block can matched by the use of the go to tag. Where is that tag and all these things? So you can come double click here. You can see this is a go to tag. Okay, here is written a go to tag. And if you are coming to the from block, so you can see here as well go to tag A. This is a go to tag A is connected to this from block. So this is connected to this indirectly. So the go to block supports the signal level propagation, and from block also supports the signal level propagation. So a few of the properties of from block, if you want to read that, the from block accept the signal from corresponding go to block, then passes it as output. The data type of the output is same as that of the input from the go to block. The data type will not be changed here. From and go to blocks allows you to pass the signals like from one block to another block without actually connecting them, and all these things. The same things here also. These also the supports the signal level propagation and all these things. Okay, so this is all about the from and go to tag. If we want to see this example, I'll make this example in front of you. Okay, where I'll be taking a sine wave as an input. Okay, sine wave as an input and connecting to a tag here. I'll change this tag name to B because already I'll be A below. Okay, and I'm connecting this here. If I'll drag down, so it will make a copy, but I'll not taking drag down. I'll delete this. Okay, and I will connect from up here. So here you can see if I'm double switching here multiple tags are available for from block. So I'll select a B because I want here B as an input sine wave. Okay. If again I am taking here sine wave, again I am connecting to the gain. As shown in the same example, I'll be preparing here that same gain value also. I'll take 6 only. And connect a scope to see the output. Okay. So instead of connecting this, I have made this for our better example, understanding of the example. So you can see here now that sine wave is connected to the B go to block, and that B go to block is connected to the gain. Then again we are multiplying this. I'll just simulate this model. Model is simulated now. We'll open this. Okay, so you can see now my sine wave amplitude is 6. The gain is multiplied with amplitude, right? It's going to 0 to 6, 6 to 1. Okay, if I am changing this gain, so my amplitude will change. Okay, if I am making it normally 1, so my amplitude will become 1, or I'll make it this 2. So you will be get some better example. Again, I have changed the gain value now. You can see in the scope now my amplitude is become a 2, and see here it's a 2 now. Okay, so that's all about that from and go to block. We will learn some next block in some next class. Thank you.